So when you talk about simply the word continuity, basically you're checking whether the function is a smooth curve without any break. That's what we mean by a continuity. Not smooth curve, I mean, it has to be just, there shouldn't be any break in the function. Now, when you look at the first graph here, you can simply see that it's a smooth curve. There is no break in the function. So we'll say it is continuous function for all the x values. Look at the second graph, which is the absolute value function here. So this also doesn't have any break because there is this extends to negative infinity, this extends to positive infinity. So there is no break in the function. While you look at here, this is called as asymptotic discontinuity, and it is considered into essential discontinuity. It's considered in because you cannot eliminate this. Now here, this is also called as jump discontinuity. So there the function has a break, but it is jump discontinuity. Now these discontinuities, thus asymptotic discontinuities and the jump discontinuities, are non-removable discontinuities. Now, if you look at the sum that uh, practice example that we did earlier, which is like you had a function which was like this was x squared. I mean, at this point, it was at x equals to 3 we had taken, and it was 9. And there was at this point there was 5 at x equals to 3. It was 5, and below that it was y equals to 3x line, which was something like this. So in this case, if you look at the function, is actually the function that was defined was that equals to x squared for x more than 3. It was equals to 3x for x less than 3, and equals to 5 at x equals to 3. Now when you look at here, the only problem is that if we can fix it up, is by just making, if I take at x equals to 3 instead of 5, if I make this y value 9, then this point, this bubble actually moves here, and this function becomes actually continuous. And this is called as a removable discontinuity. So something like asymptotes cannot be fixed up. They cannot be stick together, or they cannot be removed, otherwise the entire function is going to change. But when you actually look at the limit valuation, or the value of the function, if because just moving by one point up and down, if your graph can be continuous, then we call it is to be a basically a particular function is called as a continuous function, and in that case the type of discontinuity will be called as a removable discontinuity. So for function to be continuous, what we need to have is that, for example, if I'm checking that a function is continuous at around a point or not. So let's say I'm taking x as a. So what you're going to do is you're going to evaluate three things here. So like for limit existence, we evaluated two of them. Now here what we're going to do is we're going to do three quantities evaluation. The first one is the left hand or right hand limit, the first two. And also here it is important that it is same as the y value, exact y value at that point. So left hand limit, right hand limit, and the y value at that point, all three of them should be the same. Now the example I just gave was that y at that point, if you see at x equals to 3, y was 5, and that's why it became discontinuous. I mean, the function was not continuous, because that even there's just one point slipping down, the function breaks. So it's really important that your left hand limit, right hand limit, and the exact y value is the same at that point x equals to a. Then only we'll call the function to be continuous. So let's take some example in order to make this concept more like evident. So in this function, when we see that x cubed plus 3 when x is not equals to 0, and at x equals to 0 it's y equals to 1. So basically at this point you can see that the at exact value, so basically f of 0 is nothing but 1 for us. So that f of 0 is 1. Now what is important is we're going to evaluate the left hand and right hand limit. So as limit extends to 0 positive for the function, I'm going to use this one because it's like when the function is not equals to 0, we're going to use this. I mean the x values. So in this case it'll be 0 plus 3 is the right hand limit, which is 3, and the left hand limit is, as also I'm going to use the same function, which is f of x, which is equals to again 0 plus 3, which is 3. Now you can see the left hand limit and right hand limit both are the same, means limit exists to this point, but you can see that since it is not equals to f of 0, there is a break in the function, and this is obviously removable discontinuity. If we can fix this up, instead of having y equals to 1, if I had y equals to 3 here, then the function is actually continuous in that case. So here's another example where you want to check whether the function is continuous or not. So now if you notice here, there are 1, 2, and 3 functions, and there are possibly 2 breakpoints, because you can see the transition between the functions happening around 0 and the function transitions happening around 2. So when you're finding out the continuity of this, so let's just first find out as what's the y value when limit extends to 0 positive. So I'm going to use this function, which is obviously for higher than 0. So that's nothing but 1. So right hand limit is 1, and left hand limit, if I take for x less than 0, I mean x slightly bit lower than 0, which is obviously I'm going to use this function here. So that function is going to be 1. And the value, so f of 0 also is important. So f of 0 you can see is included in this, which is also 1. So you can see simply that at around 0, my all 3 values are the same. Hence, the function is continuous. Now let's talk about it around 2. What happens around 2? So now when I find out the value, the right hand limit around 2, so let's say 2 positive, I'm going to use this function because for higher than or equals to 2. So that's nothing but for this function it'll be 2 cubed, which is 8, plus 1, which is 9. And now when I use for left hand limit, which is limit extending to 2 negative, that's going to be negative 2 squared plus 6 times 6 times 2 plus 1. That's negative 4 plus 12 plus 1, which is 13, minus 4, which is equals to 9. And after that, you are going to check what is f of 2 as well. So f of 2 is also 9. So since you can see all 3 values are the same, so this function, when you graph it, actually, you can see a proper continuous function for the given domain. So that's what the continuity of a function means.